Now we're going to consider real GDP, which is gross domestic product adjusted for inflation. That's going to bring us to the price level. And finally, inflation, which is the rate of change in the price level. We need a few symbols to describe how real GDP is calculated in the U.S. economy or in any economy. So let's imagine there's two goods, good X and good Y. And let's imagine there's two periods in time, say 2013 and 2014. And we want to examine both the prices, P, and the quantities, Q, that pertain to 2013 or 2014. So the first equation just takes the market value of the two goods produced in the economy in 2014. And so that would be the price of good X in 2014, P super X of 14, times the quantity of X produced in 2014, Q super X of 14. And then we add in the market value of the good Y, which is P super Y times Q super Y for 2014. And that gives a measure of GDP, regular old GDP for the year 2014. You could do the same exact thing for 2013. You still have the price of good X and the quantity good X for that year. Add in the price of good Y in 2013 and the quantity of good Y in 2013. Add those together and we get GDP as we've defined it in 2013, the market value of what's produced in that year. But the problem with that measure, there may be a general inflation in the economy. The price of good X and the price of good Y may be moving up together, maybe by a whole lot from 2013 to 2014. Maybe they double, the prices double. If that's the case, you wouldn't be getting a very good comparison of how much GDP increased in that year because you'd be thinking about mostly just the general increase in prices or inflation. So to correct for that, what economists do is they try to hold prices constant as the economy grows and measure the value of production at the same price in two different periods. And that's the way to control for this inflation. So this is illustrated in the next set of equations. So for example, if we value GDP in 2014 at 2013 prices, we would multiply Q super X in 2014 by the price in 2013, Q super X of 13. And then similarly for the quantity in 2014, we'd multiply that by the price in 2013. So you can see the difference. We're evaluating GDP in 2014, but at prices in 2013. In the denominator, we are basically looking at GDP in 2013 because we're using prices in 2013 to value that production. Now, for example, when you consider the ratio of these two, you might see that the price, the total amount of GDP is 102 in 2014 and 100 in 2013. The ratio of that is 1.02%, 1.02, and that means that the real GDP, which we've now computed, has increased by 2%. So it's real now because we have kept the price constant, unlike in the very first part where prices were allowed to change. But note, there's different ways to do this. That was an example we used 2013 prices. Well, you could use 2014 prices just as well, go through the same exercise and value the production of goods X and Y in 2014 using 2014 prices, but also value the production in 2013 using 2014 prices. And when you do that, I have a little example over on the right in blue. Suppose it's $104 in 2014 and using the same prices as $101 in 2013. Here you're going to get 1.029, which suggests a real GDP growth rate of 2.9%. So the answers are somewhat different. What do economists do? Well, there's no obvious answer except to just take the average, and that's in fact what people do. They take the average of those two and get a measure now of how much real GDP has grown from 2013 to 2014. Now, what do you do over time? Because there's obviously a lot more years. There's 2009, there's 1984. So basically the same thing. You just repeat it year by year over time, and that's what this table tries to illustrate. Just repeat that process for longer periods. You kind of create a chain from the base year Suppose the base year is 2009 for the United States, which it is at this point in time. You apply this chain of percentages to get real GDP in all the years. So you can see here, I've got years 2009 up to 2015, and in between each year, right below, I show you the growth rate of real GDP that's been computed in the way I just described. So for example, from 2013 to 2014, you can see that the growth rate is 2.5%. The real GDP growth rate is 2.5%. That's what we just computed. Well, suppose the other numbers represent the growth rates between the other years. So for example, from 2009, 2010, suppose it was 2.8, and so on. So to get the real GDP in all the years, you just take what the real GDP was, or take whatever GDP was in 2009, and you grow it by 2.8%. You grow that by 2.6%. You grow that by 2.3%, and so on. And you get a whole series of real GDP, starting with this number in 2009. Usually this has to start at some point, so 2009 is where it is in this example. That's why it's called the base year. In 2009, we say real GDP and nominal GDP are equal, and so we're growing the economy at these real growth rates, starting with the actual value in 2009. What's very interesting about this is you get a byproduct of a measure of the average price in the economy. The price index, sometimes called the GDP deflator. It's just obtained by dividing nominal GDP, or just GDP for short, by real GDP. The adjective nominal referring to the fact that it's not real. And when you do this division, you kind of get a measure of the overall prices in the economy, because we computed real GDP by taking into account the increase in prices over time. So that's how it's computed. Pretty straightforward, a lot of detail the statisticians have to do. But here's what you get. Here's just a picture of what you get for the American economy from the 1940s until the present. So first of all, you see the line in red. That's good old nominal GDP, which we could have computed in any of our ways, spending, income, or value added. There's a line drawn at 2009. That's the base year for computing real GDP. So in 2009, real GDP and nominal GDP are made to be equal by definition. And then from then on, we apply those growth rates to get the blue line, real GDP. And so you can see that going beyond 2009. It's below nominal GDP because nominal GDP has those prices rising, the inflation rate, and real GDP doesn't. And then working back from 2009, you can see that real GDP is above nominal GDP at that point because it reflects prices that are higher than the actual prices, as 2009 prices. And then finally, the ratio of those two is shown by the green line, and that's the price index. That's just the ratio of nominal GDP to real GDP. The axes, it's a dual axis to represent the fact that price index has different magnitudes than either real GDP or nominal GDP. It's over on the right. The index goes like 1 or 0.8. You can see that the price index is literally 1 in 2009. That was set up that way by definition because real GDP and nominal GDP are equal in 2009. And now you can see the increase in the price level over time. So we now got a measure, a nice little measure of the price index for the economy. And as we have noted, the inflation rate is just the percentage change in that price index over time. It's the rate of which it's changing. We want to look at that in a minute, but this is a price index itself. Now, finally, there are, of course, other measures of prices and inflation in the economy. The most famous one is the Consumer Price Index, and it's computed somewhat differently. It's important to understand how. The Consumer Price Index is based on fixed quantity weights. So there's a survey that's done every so many years, not that frequently, and government statisticians, surveyors go out and try to estimate a market basket for people. How much food do you buy? How much do you spend on gasoline? How much do you spend on rent? How much do you spend on other kinds of services? It's the market basket. And those are the quantities that you want to see and use to measure how prices change over time. So once you have those quantities, then the Bureau of Labor Statistics, BLS, the agencies that is in charge of the Consumer Price Index, they conduct a survey of stores, and they go to see how the prices of these various goods in the market basket are changing. And they note that the prices are increasing or decreasing, and from that they get a measure of inflation. And it's done just as in this formula. So for example, this formula has the quantities fixed for the 2 years. You can see they're fixed at 2013. We're trying to compare the price level or the price index in 2013 and 2014. So the one at the top has 2014 prices, as it should, the price of good X in 2014, the price of good Y in 2014, but it's multiplying those by the quantity produced in 2013. And that's fixed for these two rows. 2013 quantities are in the first row and in the second row, first equation and the second equation. What changes in the two equations are the prices. So this is, in a sense, it's fixed quantity weights. The quantities are fixed, and that's another way to compute the price index. In this particular example, I've multiplied to get the value of consumption for these goods in the two periods, and I got $103 in the second period, 2014, and $100 in the first period, 2013. So since it's the same market basket, you would say that on average prices have increased by 3%. And we would say therefore the inflation rate is 3%. So that's how the Consumer Price Index is calculated. It's used for many purposes. It indexes the tax brackets in the tax system. They will move up by the change in the Consumer Price Index. It's used to index payments from the government. It's used all over the place. There's one little problem with it that you have to face, and that is it's kind of a substitution bias, economists call it. And that's because when the price of an item rises, usually you'd expect that the quantity consumed of that item will fall. And if the price of an item itself falls, you would assume that the quantity produced of that item would increase. But with fixed quantity weights, you don't let that happen. So if there's an increase in prices, we assume that there's no change in the quantity. That's what the fixed market basket means. If, in fact, there was a reduction in the quantity, you would be overstating the inflation rate by assuming there was no adjustment in the quantity, no adjustment downward. So there's a slight bias upward in the CPI, Consumer Price Index, and it's called the substitution bias because it effectively assumes people don't make that substitution. Now, finally, let's just look at the picture. We have now computed two different inflation rates. One was a byproduct of computing real GDP. We call that the GDP price index. The other was directly measured by the Consumer Price Index, how much the prices in the market basket have increased over time. And these two lines show you the changes, the percentage changes over time in those two price indices. It's, again, the rate of change is the inflation rate. And you can see they're pretty close over time. This goes back to the 1940s. They both have that blip in the early 50s. They both have this extreme high levels in the 1970s. They're both coming down in the 80s, and they both remained relatively steady since then. There's a little more volatility in the Consumer Price Index than in the GDP Price Index. GDP covers more goods and services because it includes investment, it includes government, not just what consumers spend, which is what is in the Consumer Price Index. But nonetheless, they're pretty close. It's important to note the difference, especially since some of these are used to index important government programs. We're going to now develop some models that explain not only why inflation moves up and down like this over time, but why real GDP, which you've now shown how to compute, also moves up and down over time. Thank you.